Hello everyone, in this video we are going to discuss coordinate geometry exercise 7.1. If you didn't watch my previous chapters videos, the link is in the description, watch it. Okay, the first bit is find the distance between the given points. The first point is given as 2, 3 and second point is given as 4, 1. So we know the distance formula under root x2 minus x1 whole square plus y2 minus y1 whole square. So here the given 2 points, first point I am taking as x1 y1 and second point I am taking as x2 y2. So let us substitute in the formula. Under root x2 is given as 4 minus x1 is given as 2 whole square plus y2 is given as 1 minus y1 is given as 3 whole square, which is equals to 4 minus 2 square plus 1 minus 3 minus 2 whole square, which is equals to under root 2 square 4 plus minus 2 square 4. So which is equals to root 8. Then this root 8 can be written as under root 4 into 2. Here under root 4 into 2 can be written as root 4 into root 2. Root 4 value is 2 into root 2. So the distance between given these 2 points is 2 root 2. Distance between minus 5, 7 and minus 1, 3. This first point I am taking as coordinates x1, y1 and this as x2, y2. So let us substitute in the formula. Under root x2 minus x1 whole square plus y2 minus y1 whole square, which is equals to under root, here x2 is minus 1 minus x1 is minus 5 whole square plus y2 is 3 minus y1 is 7 whole square, which is equals to under root minus 1 minus of minus 5 plus 5 whole square plus 3 minus 7 minus 4 whole square, which is equals to under root minus 1 plus 5 4 square plus of minus 4 whole square, which is equals to under root 4 square 16 plus minus 4 square 16 is equals to under root 32. So this root 32 can be written as 16 2s. Under root 16 into 2 can be separated as root 16 into root 2. Root 16 is 4 into root 2, 4 times root 2. So the distance between these given 2 points is 4 root 2. The next one is minus 2, minus 3 and 3, 2. So this I am taking as x1, y1 and x2, y2. Instead of taking this as x1, y1, if you take this as x1, y1 and this as x2, y2 also, you will get the same answer. So let us substitute in the formula. x2 minus x1 whole square plus y2 minus y1 whole square, which is equals to under root, here x2 is 3 minus x1 is minus 2 plus y2 is 2 minus y1 is minus 3, which is equals to under root 3 minus of minus plus 2 whole square plus 2 minus of minus 3 plus 3 whole square, which is equals to under root 3 plus 2 5 square plus 2 plus 3 5 square, which is equals to under root 5 square is 25 plus 5 square is 25. So which is equals to under root 50. Now this 50 can be simplified as 25 2s. So this root 25 into 2 can be separated as root 25 into root 2. Here root 25 5 into root 2, that is nothing but 5 root 2. So the distance between these given 2 points is 5 root 2. First point is a comma b and second point is minus a comma minus b. So this I am taking as x1 y1 and this I am taking as x2 y2. So under root x2 minus x1 whole square plus y2 minus y1 whole square, which is equals to under root, here x2 is minus a minus x1 is a whole square plus y2 is minus b minus y1 is b whole square is equals to under root minus a minus 2a whole square plus minus b minus 2b whole square is equals to minus 2a whole square 4a square plus minus 2b whole square 4b square. Now in the first term 4 is there, in the second term 4 is there, so I will take that 4 common under root 4 of a square plus b square. So if we separate it, root 4 into root a square plus b square. Root 4 is nothing but 2. 2 into a square plus b square. So the distance between these 2 points is 2 into under root a square plus b square. Next, second bit is find the distance between 0, 0 and 36, 15. So 0, 0 is nothing but origin. So the formula for distance is x2 minus x1 whole square plus y2 minus y1 whole square under root. This one I am taking as x1 y1 and this I am taking as x2 y2. So x2 is 36 minus 0 whole square plus y2 is 15 minus 0 whole square under root 36 minus 0 is 36. So 36 square plus 15 minus 0, 15 whole square. So under root 36 square 1296 plus 15 square 225. So which is equals to under root 1296 plus 225 1521. So under root 1521 can be simplified as 39 because 39 into 39 is 1521. So the distance between these 2 points is 39. Now here the first point is completely 0, 0, nothing but origin, and only second point is countable for us. So whenever one point is completely 0, 0 and the second point is given, simply do squarings of this second point directly from here. Under root first point 36 square plus 15 square, same answer you will get because this is all not necessary at all. So whenever origins are there, directly solve this one. Take this as only simply x and y. So you can do under root x square plus y square. Under root 36 square plus 15 square, as it is answer you will get. Next, third bit is verify whether the given points 1, 5, 2, 3 and minus 2, minus 1 are collinear or not. So first of all, what is the meaning of this collinear? 3 points. If 3 points are lying on the same straight line, then those points are called as collinear point. So for example, if the first point I am taking as A, then second point I am taking as B, third point I am taking as C. 3 points A, B, C are on a single straight line, then these 3 points A, B, C are called as collinear. So this is AB and this is BC. So if we add these two, AB plus BC, this part plus this part is nothing but total part AC. So AB plus BC is nothing but total part AC. So this is the logic we need to remember while solving the collinear. Okay, now first this 1, 5 I am taking as some point A and 2, 3 some point I am taking B. And here he didn't mention anywhere that this is the exact order, because this is particularly A only, this is particularly B only, this is particularly C only. It may be A or it may be B, it may be C, it may be B, whatever it may be. Okay, the order is not exactly mentioned here. So if this is the A point, if this is the point B, let us check now. First I will find the distance between this A and B. This I am taking as x1 y1 and this I am taking as x2 y2. So under root x2 minus x1, 2 minus 1, 1 square plus y2 minus y1, 3 minus 5 minus 2 whole square which is equals to 1 square is 1 plus minus 2 square is 4, which is equals to root 5. Next, this I am taking as C. So now I am going to find the distance between these BC points. Here I will write AB point. This I am going to find BC point. So again same under root. This I am taking as x1 y1 and this I will take x2 y2. x2 minus x1 minus 2 minus 2 minus 4 whole square plus y2 minus y1 minus 1 minus 3 minus 4 whole square is equals to under root minus 4 whole square 16 plus minus 4 whole square 16, which is equals to here plus 16 is nothing but 32 root 32. Root 32 is 4 root 2. Next, this is BC distance. The same way I am going to find the AC distance. Here A, here C. x2 minus x1 minus 2 minus 1 minus 3 whole square plus y2 minus y1 minus 1 minus 5 minus 6 whole square, which is equals to minus 3 square 9 plus minus 6 square 36 under root is equals to root 45, can be written as 3 root 5. Now any 2 points, either these two or else these two or else these two, any 2 points, I mean any 2 distances, if we add, we need to get the third distance. Root 5 plus 4 root 2 not possible to addition. 4 root 2 3 root 5 not possible to do addition. Root 5 plus 3 root 5 is 4 root 5, but here it is 4 root 2. So if we add any 2 distances, we are not getting the third one, so it means these are not collinear. Okay, bit number 4. Check whether 5 comma minus 2, 6 comma 4 and 7 comma minus 2 are the vertices of an isosceles triangle. So for example, if we have 3 points and these 3 points are exactly on the same straight line. Next, 3 points are there where 1 point is completely different from the remaining 2 points. Next, one more point is there. Now, in the first case, all the 3 points are lying on the same straight line. In the second case, 2 points are on the same straight line and one is on another. And here also again 2 points are on the same straight line and one is at the other. Here in this case we are not getting any triangle, whereas in these 2 cases we are getting the triangle. So from these figures we can conclude one thing, that is, if the points are collinear, drawing a triangle is not possible, otherwise it is possible. So first we need to check whether these 3 points are collinear points or not. If these 3 points are collinear to each other, so it is not possible to construct a triangle. If these 3 are not collinear points, yes, we can construct the triangle. So first I am taking this as point A and this as point B. Let us find the distance between these two. This is x1 y1 and this is x2 y2. So the first distance, x2 minus x1, that is 6 minus 5 whole square plus y2 minus y1, here 4 minus of minus 2 whole square, under root 6 minus 5 1 square plus 4 minus of minus plus 4 plus 2 6 square, which is equals to under root 1 square is 1 plus 6 square is 36. 1 plus 36, 37. So the distance between the first 2 points is root 37. Now I will find the distance between these 2 points. This one I will make it as x1 y1 and this I will make it as x2 y2. So under root x2 minus x1, here 7, here 6, 7 minus 6 1 square plus y2 minus y1, here y2 is minus 2, here y1 is 4, minus 2 minus 4 minus 6 whole square is equals to under root 1 square is 1 minus 6 square is 36, 1 plus 36, 37. Next, finding the distance between this A and C. Here x1 y1, here x2 y2. Under root x2 minus x1, 7 minus 5 2 square plus minus 2 minus of minus 2 means plus 2 minus 2 plus 2 0 0 square, which is equals to under root 2 square 4 is nothing but 2. Now any 2 points if we add, otherwise any two distances if we add, we need to get the third one. Root 37 it is not 2 plus root 37 not possible to simplify, 2 plus root 37 not possible to simplify. So we can clearly say that these 3 points are not collinear. These 3 points are not collinear. If those 3 are not collinear, then obviously we can draw a triangle. So he is saying check whether are the vertices of isosceles or triangle. First we can confirm yes, these are vertices of triangle, but he is asking isosceles or not. Here one measurement is root 37, second distance is root 37. Two sides are equal to each other, then obviously it is an isosceles triangle. The question number 6 is, show that the following points form an equilateral triangle. Point A is a comma 0 and point B minus a comma 0 and point C is 0 comma a root 3. So first I am taking the AB and I will find the distance between these two. So this I am taking as x1 y1 and this as x2 y2. So the distance between AB is equals to under root x2 minus x1. Here x2 is minus a and x1 is a. So minus a minus a whole square plus y2 minus y1. This is 0, this is 0. 0 minus 0 whole square, which is equals to under root minus a minus 2a whole square. This is 0 only, so that's why I am not writing that. Minus 2a whole square, 4a square. So root 4 is 2, a square is a. So the distance between the points A and B is 2a. Next, I'll find the distance between this B and C now. So BC is equals to under root, this is x1 y1 and this as x2 y2. So x2 minus x1, here it is 0, this is minus a, it's already minus a, so it will become plus a. 0 plus a square plus y2 minus y1, this is a root 3, this is 0, a root 3 minus 0, a root 3 whole square, which is equals to under root a square plus a root 3 whole square, 3a square, which is equals to a square plus 3a square, 4a square. Under root 4a square is 2a. AB completed, BC completed. Now I'll find the distance between CA or AC. x2 minus x1, 0 minus a whole square plus y2 minus y1, a root 3 minus 0, a root 3 whole square. Under root minus a square plus a root 3 whole square, 3a square, which is equals to under root 4a square, nothing but 2a. AB distance is 2a, BC distance is 2a, CA distance is also 2a. All the sides are equal in length. So we can conclude that it is an equilateral triangle. Okay, question number 7 is, prove that the points minus 7 comma minus 3 5 comma 10 15 comma 8 and 3 comma minus 5 are the corners of a parallelogram. Here corner is nothing but vertex. He is asking to show that those 4 points are vertices of a parallelogram. So we have a parallelogram with the measurements minus 7 minus 3 and second vertex is 5 comma 10 and third vertex is 15 comma 8 and fourth vertex is 3 comma minus 5. So now what is the property of a parallelogram? Opposite sides are equal. These two sides measurements should be equal as well as these two sides measurements should be equal. So not to have any confusion, I am writing the alphabets also. This is point A, point B, point C and point D. Actually these alphabets are outside, but already outside numbers are there. So not to have any confusion, that's why I am writing inside. That's it. Okay, now let us find the distance between AB. This is x1 y1, this is x2 y2. So under root of x2 minus x1. x2 is 5 and x1 is minus 7. So 5 minus, this is x2 minus x1 how much? Again minus 7 whole square plus y2 minus y1. y2 is 10 minus y1 is minus 3 whole square, which is equals to under root 5 minus of minus plus 5 plus 7 12 square plus 10 minus of minus plus 10 plus 3 13 square, which is equals to under root 12 square 144 plus 13 square is 169. So if we simplify it, is equals to under root 9 plus 4 13, 3 1 carry, 6 7 11, 1 carry, 1 2 3. So under root 313. Next, AB completed. Now I will find CD distance also. CD is equals to under root, this I am taking as x1 y1 and this as x2 y2. x2 minus x1, here 15 minus x1 is 3 whole square plus y2 is 8 minus y1 is minus 5 whole square, which is equals to 15 minus 3 12 square plus 8 minus of minus plus 8 plus 5 13 square is equals to under root 12 square is 144 plus 13 square is 169, which is equals to under root 313. AB distance is root 313, CD distance is also root 313. This AB as 3 root 313, this CD distance root 313. These two opposite sides got equal values. Now we need to confirm these two also. Let us find AD distance, then after BC distance. Okay, now let us find out the distance between AD. So AD is equals to this I will take it as x1 y1 and this as x2 y2. Under root x2 is 3 minus x1 is minus 7 plus y2 is minus 5 minus y1 is minus 3 whole square, which is equals to under root 3 minus of minus plus 3 plus 7 10 square plus minus 5 minus of minus plus minus 5 plus 3 minus 2 whole square is equals to under root 10 square is 100 plus minus 2 square is 4, so which is equals to 104. Next, the same way I'll find the BC distance also. So this I will take it as x1 y1 and this as x2 y2. So BC is equals to under root x2 minus x1 15 minus 5 whole square plus y2 minus y1 8 minus 10 whole square is equals to under root 15 minus 5 10 square 100 plus 8 minus 10 minus 2 whole square 4, which is equals to under root 104. So here AD distance we got as root 104 and BC distance also we got as root 104. So if we observe the opposite sides now, here AB is root 313, here also CD is root 313. Opposite sides are equal. AD is root 104 and here BC is root 104. Opposite sides are equal to one another. So if opposite sides are equal to each other, the figure is maybe rectangle or maybe parallelogram. So in this case we cannot conclude exactly it is parallelogram because it may be parallelogram and may be rectangle. Then how we can conclude it is a parallelogram? By finding the diagonals. So we need to find out the diagonal BD as well as we need to find out the diagonal AC. If those two measurements are equal, then it is a rectangle. If those two diagonals are different in length, then that is a parallelogram. So let us check this AC and BD measurements. Okay, now first I am going to find this diagonal AC. This I am taking as x1 y1 and this I am taking as x2 y2. So AC is equals to under root x2 minus x1, here it is 15, this is already minus 7, so minus of minus 7 plus 7, 15 minus of minus 7 whole square plus y2 minus y1, here it is 8 minus y1 is minus 3 whole square, which is equals to under root 15 minus into minus plus 15 plus 7 22 square plus minus of minus plus 8 plus 3 11 square is equals to under root 22 square 484 plus 11 square 121 is equals to under root 484 plus 121 605. This is one of the diagonals. Now let us find the diagonal BD. Here this I am taking as x1 y1 and this as x2 y2. So BD is equals to under root x2 minus x1, here it is 3, here it is 5, 3 minus 5 whole square plus y2 minus y1, this is minus 5, that is minus 10, minus 5 minus 10 whole square is equals to 3 minus 5 minus 2 whole square 4 plus minus 5 minus 10 minus 15 square 225 is equals to under root 4 plus 225 229. Now if we observe the diagonals here clearly, the first diagonal is under root 605 and the second diagonal is under 229. Both are completely different. So from these all 6 measurements we can conclude AB is equals to CD, AD is equals to BC. Already we solved, these opposite sides are equal. Now diagonals AC BD, AC is not equals to BD. Opposite sides are equal to each other but the diagonals are not equal, so that's why these points are vertices of a parallelogram. And question number 8 is, show that the points taken in order are the vertices of a rhombus. Then find its area. And the points are given as minus 4 comma minus 7, minus 1 comma 2, 8 comma 5 and 5 comma minus 4. So if we have a rhombus, something A, B, C, D. If all the 4 sides are equal, then it is a rhombus, as well as 2 diagonals should not be equal. If all the 4 sides are equal to each other, it may be a square or else it may be a rhombus. Whereas in square, the diagonals are equal. In rhombus, the diagonals are not equal. So 4 sides should be equal to each other and diagonals should not be equal. So let us take this as A and this as B. So this will become x1 y1 and this is x2 y2. Now let us find this distance AB. So AB is equals to under root x2 minus 1 minus x1 minus 4 whole square plus y2 is 2 minus y1 is minus 7 whole square is equals to under root minus 1 minus of minus 4 plus 4 whole square plus 2 minus of minus plus 7 whole square is equals to under root minus 1 plus 4 3 square plus 2 plus 7 9 square is equals to under root 3 square is 9 plus 9 square is 81 is equals to root 90. Now the same way I am going to find this BC distance. So this is point B and this is point C. So this will become now x1 y1 and this will become x2 y2 under root x2 minus x1. It's already minus 1, so it will become plus 1. Now 8 plus 1 9 square plus y2 minus y1 5 minus 2 3 square is equals to under root 9 square 81 plus 3 square is 9 under root 90. Now AB distance completed, BC distance completed. Now let us move to finding CD distance. So this will become C, this will become D. So this is x1 y1 and here it is x2 y2. Okay, this is point C and this is point D. So this I am taking as x1 y1 and this as x2 y2. Let us find the distance between this CD. Under root x2 minus x1, 5 minus 8 minus 3 whole square plus y2 minus y1, this is minus 4 minus 5, minus 4 minus 5 minus 9 whole square, which is equals to under root minus 3 square is 9 plus minus 9 square is 81. Under root 9 plus 81, 90. So the distance between C and D is 90. Now let us take the point D and point A. Point D is 5 comma minus 4 and point A is minus 4 comma minus 7. This is point D and this is point A. Okay, now let us find the distance between AD or DA. x2 minus x1 minus 4 minus 5 minus 9 whole square plus y2 minus y1, this is already minus 1, so it will become plus, minus 7 plus 4 minus 3 whole square, so which is equals to under root minus 9 whole square is 81 plus minus 3 whole square is 9 is equals to root 90. So all the four sides we got as root 90, root 90, root 90, root 90 only. Now let us find the diagonals. One of the diagonal BD. So point B is minus 1 comma 2 and point D is 5 comma minus 4. So let us find the distance between these two first. BD is equals to, this I am taking as x1 y1 and this as x2 y2. x2 minus x1, 5 minus of minus 1 plus 5 plus 1, 6 square plus y2 minus y1 minus 4 minus 2 minus 6 whole square under root. This is equals to root 6 square 36 plus minus 6 square 36, root 36 plus 36 72. Next, one more diagonal AC. Point A is minus 4 comma minus 7 and point C is 8 comma 5. So let us find the distance between this AC. This I am taking as x1 y1 and this as x2 y2. x2 minus x1, 8 minus of minus 4 plus 4, 8 plus 4, 12 square plus 5 minus of minus 7 plus 7, 5 plus 7, 12 square is equals to under root 12 square 144 plus 12 square 144 is nothing but under root 288. If we observe here, one of the diagonals is 72 and the second diagonal is under root 288. Both are different. So from these all four distances we can conclude that is AB is equals to BC is equals to CD is equals to DA. All the four sides are equal, whereas the diagonals AC is not equals to BD. So we can confirm that the vertices are of rhombus. Next, he asked find its area also. So just now we got the diagonals AC as well as BD, and now we need to find the area of this rhombus. So area of the rhombus is equals to half into diagonal 1 into diagonal 2. Area of rhombus is equals to half into diagonal 1 into diagonal 2. Half into one of the diagonals we got as under root 72 into, and the second diagonal we got as under root 288. So which is equals to 1 by 2 into this root 72 can be written as under root 36 2za into under root this 288 can be written as 144 2za. So we will get it as 1 by 2 into root 36 is 6 root 2 into root 144 is 12 root 2, which is equals to half into 6 into number 12 into root 2 into root 2. So here 2 will get cancelled, so we remains with 6 into 12, 72. And here he didn't mention anything about the units, so that's why simply I'm writing unit square. 72 units square. The ninth bit is Name the type of quadrilateral formed. He gave 4 vertices. By using the distance formula, we need to find out which type of quadrilateral it is. Some kind of quadrilateral is there, we don't know which one is particular it is. This is -1 comma -2, and this is 1 comma 0, and this is -1 comma 2, and this is -3 comma 0. So not to having any confusion, I'm naming it A, B, C, D. So A, B, C, D, one quadrilateral is there. First let us find this AB distance. AB is equals to under root. This is x1, y1, and this is x2, y2. So we want x2 minus x1, 1. Here already minus is there. So minus of -1 plus 1 plus 1, 2 whole square plus y2 minus y1. Here 0. Here already minus is there. So minus of minus plus 0 plus 2, 2 square. So we will get 2 square is 4 plus 2 square is 4. Root 8. What is the value of root 8? 2 root 2. Next, I am going to find this BC distance. This is already x2, y2. So I am taking these as x1, y1. x2 minus x1, 1. This is already -1. So minus of -1 plus 1. 1 plus 1, 2 square plus. Here it is 0. It is -2. 0 minus 2 minus 2 whole square, which is equals to under root 2 square 4 plus -2 square 4 root 8. Nothing but 2 root 2. Next, CD distance I am going to find. This is already x1, y1. So this I am taking as x2, y2. x2 minus x1. This is already -1. Now it will become +1. -3 plus 1 minus 2 whole square plus y2 minus y1. 0 minus 2 minus 2 whole square under root, which is equals to -2 square 4 minus 2 square 4. 4 plus 4, 8 root 8. Root 8 is nothing but 2 root 2. Next, I am going to find DA, otherwise AD distance. x2, y2, x1, y1. x2 minus x1 -3. This is already -1, so it will become +1. -3 plus 1 minus 2 whole square. 0. This is already -2, so it will become minus of -2 plus 2. 0 plus 2, 2 square, which is nothing but root 2 square 4, root 2 square, sorry, -2 square 4, 2 square 4, 4 plus 4, 8 is equals to 2 root 2. If we observe here, AB value is 2 root 2, BC is 2 root 2, CD is 2 root 2, as well as DA also 2 root 2. All the 4 sides are equal to each other. If all the 4 sides are equal to each other, it may be square or it may be rhombus. So to confirm whether it is a square or rhombus, we need to find the diagonals also. Let us check the diagonals. First diagonal AC. AC distance. I am taking this as x2, y2, and this is x1, y1. x2 minus x1. This is already -1. Now it will become +1. -1 plus 1, 0, 0 square. Plus. This is already -2. Now it will become +2. 2 plus 2, 4, 4 square, which is equals to under root 16, nothing but 4. Now this distance BD. This is already x2, y2. This one I am taking as x1, y1. x2 minus x1. This is already -3. Now it will become +3. So 1 plus 3, 4 square plus 0, 0. So 0 square is equals to under root 16, nothing but 4. So if we observe now from all these distances, AB is equals to BC equals to CD equals to DA. All the 4 sides are equal to each other, as well as AC is equals to BD. Diagonals also equal to each other. If all the 4 sides are equal to each other as well as the diagonals also equal to each other, then the quadrilateral is a square. So these points are of the quadrilateral square. The next question is, again I am taking one of the quadrilaterals. First one is -3 comma 5. Second one 3 comma 1. Then 1 comma -3. Then -5 comma 1. This I am taking point A, point B, point C, and point D. So first I am going to find AB distance. This I am taking as x1, y1, and this as x2, y2. So x2 minus x1. This is already -3. Now it will become +3. 3 plus 3, 6 square plus 1 minus 5 minus 4 whole square, which is nothing but 6 square 36 plus 4 square 16, 36 plus 16 under root 52. Now I am going to find BC distance. This is already x2 y2, so this one I am taking as x1 y1. x2 minus x1, 3 minus 1 2 square plus this is already minus 3, now it will become plus 3, 1 plus 3 4 4 square is equals to under root 2 square is 4 plus 4 square is 16, which is equals to root 20. Next CD distance I am finding. This is already x1 y1, so this I am taking as x2 y2. x2 minus x1 minus 5 minus 1 minus 6 whole square plus 1 minus of minus 3 plus 3, so 1 plus 3 4 square is equals to minus 6 square is 36 plus 4 square is 16 under root 36 plus 16 52. Next DA distance under root minus 5, this will become plus minus 5 plus 3 minus 2 whole square plus 1 minus 5 minus 4 whole square is equals to minus 2 square 4 plus minus 4 square 16, 4 plus 16 root 20. Now if we observe, AB value is root 52, CD value is root 52, BC root 20, DA root 20. AB, CD both the values are same. AD, BC both the values are same. Opposite sides are equal to each other. If opposite sides are equal to each other, two quadrilaterals are possible. One is rectangle and one is parallelogram. So which one is our correct quadrilateral, we will decide by finding the diagonals. So let us find AC. This I am taking as x2 y2 under root. Now this is minus 3, it will become plus 3. 1 plus 3 4 square plus minus 3 minus 5 minus 8 whole square is equals to under root 4 square 16 plus minus 8 square 64 under root 16 plus 64 root 80. Next the same way I am going to find this diagonal BD under root. This I am taking as x1 y1. x2 minus x1 minus 5 minus 3 minus 8 whole square plus 1 minus 1 0 square, which is equals to under root 64 nothing but 8. Opposite sides are equal to each other but diagonals are not equal, so this is a parallelogram. Next third question is 4, 5, 7, 6, 4, 3 and 1, 2. So we have some quadrilateral ABCD. Point A is 4, 5 and point B is 7, 6 and point C is 4, 3 and point D is 1, 2. So first I am going to find AB distance. AB is equals to under root here A, here B. So this I am taking as x1 y1 and this as x2 y2. x2 minus x1 7 minus 4 3 square plus y2 minus y1 whole square 6 minus 5 1 square is equals to under root 3 square is 9 plus 1, that is root 10. Next the same way I am going to find BC distance. This is already x2 y1 2, so this I am taking as x1 y1. x2 minus x1 7 minus 4 3 square plus 6 minus 3 3 square is equals to here under root 3 square 9 plus 3 square 9, 9 plus 9 18 root 18. Next CD distance. CD is equals to this I am taking as x2 y2. 1 minus 4 minus 3 whole square plus 2 minus 3 minus 1 whole square under root, which is equals to minus 3 square 9 plus minus 1 square 1, which is equals to root 10. Then DA I am finding 1 minus 4 minus 3 whole square plus 2 minus 5 minus 3 whole square which is equals to minus 3 square 9 plus minus 3 square 9, root 9 plus root 9 18. So here AB value is root 10 as well as CD is root 10. AB and CD both are same. AD value is root 18, BC value is root 18. Here also both the values are equal. Opposite sides are equal to each other. So it may be parallelogram or it may be rectangle. Then let us find the diagonals also. First I am finding BD distance. This I am taking as x1, y1. 7 minus 1, 6 square, plus 6 minus 2, 4 square, is equals to under root 6 square 36 plus 4 square 16 is equals to under root 52. The same way AC distance also I am finding. This I am taking as x2, y2. x2 minus x1, 4 minus 4, 0 square, plus 3 minus 5, minus 2 square. Here 0 square is 0, minus 2 square is 4. Under root 4 is nothing but 2. So from this we can conclude AB is equals to CD, BC is equals to DA, then AC not equals to BD. Opposite sides are equal to each other but diagonals are not equal. So we can conclude this is parallelogram. In case if diagonals are also equal, then it will become rectangle, otherwise parallelogram. Then question number 10. Find the point on the x-axis which is equidistant from 2 comma minus 5 and minus 2 comma 9. So if you observe here, somewhere here we have x-axis and 2 points are there. With this, somewhere these 2 points are there. For example, one point is here 2 comma minus 5 and second point somewhere here minus 2 comma 9. Now find a point on the x-axis. Somewhere on the x-axis one more point is there which is equidistant. Here to here, how much distance is there? The same distance will be there from here to here also. So on the x-axis point I am taking as P. This is point A and this is point B. So he said very clearly that these two are equidistant. So we can conclude PA is equals to PB. PA is equals to PB. Then what about this point P? It is on x-axis. So x coordinate will be there but y coordinate is 0. Now let us find this PA value as well as PB value also. Okay, we know the distance formula under root x2 minus x1 whole square plus y2 minus y1 whole square. So here I am taking this as x1 y1 and this as x2 y2. Okay, so first I am going to find PA under root x2 minus x1 x minus 2 whole square plus y2 minus y1 here 0 minus minus 5 whole square and is equals to PB. This is P, this is B. This B I am taking as x1 y1. So x2 minus x1 x minus of minus 2 whole square plus y2 is 0 minus 9 whole square under root. Now to remove these square roots on both the sides, I will do squaring on both the sides. So if you do squaring on both sides, is completely square. This is also completely square. Here square, square root cancel, square, square root cancel. So we remains with x minus 2 whole square, x minus 2 whole square plus minus of minus plus 0 plus 5 square 25 is equals to minus of minus plus x plus 2 whole square plus 0 minus 9 minus 9 square 81. Now this total equation we need to solve for the x value. Okay, this x minus 2 whole square, it is in the form of a minus b whole square. So if we expand, x square plus 4 minus 2 into x into 2, 4x plus 25 is equals to, here x plus 2 whole square is in the form of a plus b whole square. So if we expand it, x square plus 4 plus 4x plus 81. Left side x square, right side x square. left side 4, right side 4 cancel. So remaining all, this plus 4x I will take to the left side. Here already minus 4x is there. Now this plus 4x if we bring to left side it will become minus 4x is equals to, here 81 is there as it is. This plus 25 if we bring to the right side it will become minus 25. Minus 4x minus 4x minus 8x is equals to 81 minus 25. 81 minus 25, 11 minus 5, 6, 56. So now we want x value. So x is equals to 56 divided by minus 8. 8 ones are 8 sevens are. So x is equals to minus 7. And we want exactly where it is touching the x-axis. So already we took somewhere it is touching on the x-axis. That point is x comma 0. Because it is touching on the x-axis, so x coordinate will be there compulsory. It is touching on the x-axis, so that's why y coordinate is 0. Now in the place of this x, substitute minus 7. So minus 7 comma 0. Question number 11. If the distance between 2 points x comma 7 and 1 comma 15 is 10, then find x value. If the distance between 2 points, this x comma 7 I am taking as x1 y1 and 1 comma 15 I am taking as x2 y2. Let us find the distance. x2 minus x1, 1 minus x whole square plus y2 minus y1, 15 minus 7 whole square. And this distance is given as 10. Here under root 1 minus x whole square plus 15 minus 7, 8 square is equals to 10. To remove this square root, I will do squaring on both the sides. Squaring on both the sides. So here square root will get cancelled. 1 minus x whole square plus 8 square is equals to 10 square. This 1 minus x whole square is equals to 10 square is 100 minus this plus 8 square I am taking to the right side. 8 square is nothing but 64. So now 1 minus x whole square is equals to 100 minus 64, 36. Then 1 minus x whole square is 36. Then what about 1 minus x? 1 minus x is equals to plus or minus under root 36. 1 minus x is equals to plus or minus root 36. 6. Now let us take one time plus 6 and one time minus 6. 1 minus x is equals to plus 6 or 1 minus x is equals to minus 6. Now this minus x I will take to right side, plus 6 I will bring to the left side. 1 as it is, plus 6 will become minus 6 is equals to minus x will become plus 6. So x is equals to 1 minus 6 minus 5. Or here minus x I will take to another side and minus 6 I will bring to the left side. 1 as it is, minus 6 will become plus 6 is equals to minus x will become plus x. So x is equals to 1 plus 6, 7. So x value is minus 5 or plus 7. Next question number 12 is, find the values of y for which the distance between the points p2 comma minus 3 and q 10 comma y is 10 units, same like the previous problem. Let us find the distance between pq. This value I am taking as x1 y1 and this I am taking as x2 y2. Under root x2 minus x1, 10 minus 2 whole square plus y2 minus y1. Here y minus y1 is again minus 3 whole square. The distance is equals to 10 units. So under root 10 minus 2, 8 square plus y minus of minus 3 plus 3 whole square is equals to 10. Now to remove this square root I will do squaring on both the sides. So we will get 8 square plus y plus 3 whole square is equals to 10 square. This 8 square I will take to the right side. We remains with y plus 3 whole square is equals to 10 square is 100 minus 8 square 64. So y plus 3 whole square is equals to 100 minus 64, 36. Y plus 3 whole square is 36. Then what about y plus 3 value? Plus or minus 6. Let us take ones plus, ones minus. Y plus 3 is equals to plus 6, or y plus 3 is equals to minus 6. So plus 3, if we take another side, it will become minus 3. Y is equals to 6 minus 3. Y is equals to 3. Plus 3, I will take right side, it will become minus 3. So y is equals to minus 6 minus 3. Y is equals to minus 9. So y values are 3 or minus 9. And next question number 13 is, find the radius of the circle whose center is 3 comma 2 and passes through minus 5 comma 6. We have a circle, center, this is the radius. So this center is given as 3 comma 2 and it is passing through this point minus 5 comma 6. We need to find this radius. Here the radius is nothing but distance between these 2 points. So simply we need to find the distance. This I am taking as x1 y1 and this points as x2 y2. So let us substitute in that. x2 minus x1 minus 5 minus 3 whole square plus y2 minus y1 6 minus 2 whole square, which is equals to under root minus 5 minus 3 minus 8 whole square plus 6 minus 2 4 square is equals to under root minus 8 square 64 plus 4 square 16 is equals to under root 64 plus 16 80. So this root 80 can be written as under root 16 5 so root 16 is 4 into root 5 as it is. So the radius of the given circle is 4 root 5. Next question number 14 is, can you draw a triangle with the given vertices 1 comma 5 5 comma 8 and 13 comma 14. So previously also we solved one kind of question like this. If all the 3 given points are collinear, it is not possible to draw or construct a triangle. Otherwise it is possible. Okay, let us check it now. First I am taking this as point A and this as point B and this as point C. So first I am going to find the distance between AB. This is x1 y1 and this as x2 y2. Under root x2 minus x1 whole square. Here x2 is 5, x1 is 1. 5 minus 1 whole square plus y2 minus y1. y2 is 8, y1 is 5. 8 minus 5 whole square is equals to under root 5 minus 1 4 square plus 8 minus 5 3 square is equals to 4 square 16 plus 3 square 9. Under root 16 plus 9 25. Under root 25 5. Next I'll find BC distance. Under root, this I already we took as x2 y2, so this I am taking as x1 y1. x2 minus x1 5 minus 13 whole square plus y2 minus y1 8 minus 14 whole square is equals to under root 5 minus 13 minus 8 whole square plus 8 minus 14 minus 6 whole square is equals to under root minus 8 square 64 plus minus 6 square 36 is equals to under root 64 plus 36 100, which is equals to 10. Next CA. This I am taking as x2 y2. This already x1 y1. x2 minus x1 1 minus 13 minus 12 whole square plus 5 minus 14 minus 9 whole square. Minus 12 whole square 144 plus minus 9 square 81. So if we add these two, 225, which is nothing but 15. Here AB value is 5, BC is 10, CA is 15. So AB plus BC. AB plus BC, that is 5 plus 10 is equals to 15, which is nothing but CA. sum of the two sides or two measurements is equal to the third one. So we can say that it won't form a triangle because these 3 points will lie exactly on the same line. This AB measurement plus BC measurement is exactly equals to the total measurement. So the given 3 points are collinear points, so it is not possible to draw a triangle with those given vertices. Okay, let us discuss the last question in this exercise. Find a relation between x and y such that the point x comma y is equidistant from the points minus 2 comma 8 and minus 3 comma minus 5. 2 points are there. One point is minus 2 comma 8 and one more point is minus 3 comma minus 5. And for these 2 points, somewhere one more point is there. And that point he mentioned as x comma y. So this point I am taking as P, this as A and this as B. And he clearly said that it is equidistant. So it means this PB distance is exactly equals to this PA distance. So first let me find the PA distance. Under root. Okay, this x1 y1 and this x2 y2. x2 minus x1. Here it is x. This minus of minus 2 plus 2 whole square plus y2 minus y1 y minus 8 whole square, which is equals to under root x plus 2 whole square, x square plus 4 plus 4x plus y minus 8 whole square, y square plus 64 minus 16x. Next, the same way I will find this PB distance also. This I am taking as x1 y1. x2 minus x1, x minus of minus 3 plus 3, x plus 3 whole square plus y2 minus y1, this is y minus of minus 5 plus 5, y plus 5 whole square under root. If we expand it, we will get x plus 3 whole square, x square plus 9 plus 6x, y plus 5 whole square, y square plus 25 plus 10y. Now he said that clearly it is equidistant, so it means PA distance is exactly equals to PB distance. So PA is equals to PB means PA square is equals to PB square. So for these two, if we do squares, here square root, both will get cancelled. So both are equidistant. I made PA distance is equals to PB distance. Now to remove that square roots, both the sides I will do squaring on both the sides. So here square root square cancel, square root square cancel. So remaining with here x square, this is 4, this is 64, 4 plus 64, 68 plus 4x minus 16x minus 12x plus y square is equals to here x square oh sorry, not a small mistake, this is y. So here x square 4 plus 64 68 plus 4x minus 16y plus y square is equals to x square plus y square plus 6x plus 10y plus 9 plus 25, 34. Left side x square, right side x square cancel, left side y square, right side y square cancel. Now I will bring everything to one side. Here 68 as it is plus 4x minus 16y plus 6x will become minus 6x plus 10y will become minus 10y plus 34 will become minus 34 is equals to 0. Now 68 minus 34, 4x minus 6x minus 2x minus 16y minus 10y minus 26y is equals to 0. Okay, here 34 will come in 2 table, 2 will come in 2 table, 26 will come in 2 table. So every term I will divide by 2, by 2, by 2, by 2. So here 34 by 2 17 minus 2x by 2 x minus 26 by 2 13y is equals to 0. This minus x minus 13y I will take to another side. So minus x will become plus x, minus 13y will become plus 13y is equals to 17. So the equation is, or else relation is, x plus 13y is equals to 17. Till now, if you didn't subscribe to my channel, subscribe for more videos. Thank you.